So we've looked at non-rechargeable cells. What we're going to do now is look at rechargeable cells. Rechargeable cells are designed to be used more than once. So in these ones, what you'll see is if you looked at the EMF over time, you'll see that you'll use them up, but then you'll recharge them. And then you'll use them up, and then you'll recharge them, and so on. So you will be able to send them backwards and forwards. So what we're looking at here, we're looking at maybe things like the lead acid battery in your car. When you drive the car around, it recharges it. Okay, we're looking at the lithium-ion batteries in your phones and laptops. Or maybe like the nickel-cadmium batteries that you might get in a rechargeable radio device, or torch, rechargeable torch. So there's different uses. The top two being very much more important probably than the bottom one. And the one we're going to focus on, the one the exam board wants us to focus on, is that middle one, because obviously much more relatable for yourselves. That you've got your laptops, your tablets and your smartphones. So why do we use lithium? Well, we use lithium because it's the least dense metal. So it's light. And these two reactions are what is happening in your lithium-ion cell. And these are quoted in the specification, so it would be my advice that you learn these two. At the positive electrode, we can see reduction is happening. We can see we're gaining electrons. And at the negative electrode, we've got oxidation happening. And remember, looking at these, they're actually already written the right way around. They've not both been written as reductions. They've been written as the reaction at the positive and the reaction at the negative. So at the positive electrode, which thing is reduced? So have a look at oxidation states and see if you can decide what is reduced. And we can see that it's the cobalt in the oxidation state 4 is reduced to cobalt in oxidation state 3. And at the negative electrode, lithium is oxidized to lithium 1+ ions. Could you combine those two equations to make an overall equation? Well, there we go, if you have a look, that's what you end up with. Now just spot there, notice that the lithium ions cancel. That's interesting because the lithium ions are actually your electrolyte. They are the thing that maintains the balance of charge. They're going to be flowing between the electrodes of the cell. So they're the ions that are going to move. As the electrons move around the external circuit, the lithium ions are going to move essentially across what would be this version of the salt bridge. So if this is how the cell's discharged, how would the cell be recharged? We would just have to reverse it. So we reverse the whole process, take that complex and we turn it back into lithium and this cobalt 4 oxide formula, and we'll be recharging it. The lithium ions that are cancelling out are the things balancing the charge. They're the flow of ions as electrons flow through the wires.